Okay, we're looking at practice test 2, problem number 4. As I've stated before, if you want to get the best results out of these problems, whenever I ask a question or ask you to do a calculation, pause the video, try your hand at it first, and then continue the video. All right, we have an object suspended on a string. It's being spun in a circular motion with a radius of 0.4 meter. Question is, what speed is required to keep the object in uniform circular motion at a radius of 0.4 meter? First, let's start by drawing a free body diagram of the object. I've drawn the free body diagram. We have the force of tension in this direction, and then we have the force of gravity in the downward direction. Of course, at this particular location, we have that the centripetal acceleration points toward the center, which would be the negative x direction. Write Newton's second law of motion for the object in the xy direction. Okay, for the x components, the sum of the forces in the x direction equals the mass times acceleration, which states that the force of tension times the cosine of theta is equal to the mass times acceleration. Notice that that force of tension cosine theta is the only force supplying the centripetal force. And for the y component, sum of forces in the y direction equals 0. The object is not moving vertically. Ft sine theta minus mg equals 0. Solve for the force of tension. Force of tension times sine theta equal to the force of gravity, and that results in the force of tension equal to the force of gravity divided by the sine of theta. Solve for the centripetal acceleration. We have the force of tension times cosine theta is equal to the centripetal force, m times the centripetal acceleration. We can substitute for Ft this quantity here. All we've done is go over here and substitute. And then we can solve for the centripetal acceleration. This centripetal acceleration is equal to the g times the cosine theta divided by sine theta. Now solve for v. What do we know about the relationship between the centripetal acceleration and v? Of course, centripetal acceleration is v squared over r. We know AC equal v squared over r equal g cosine theta over sine theta. We can now solve it with a little bit of algebra, setting up that v is equal to the square root of the gravitational constant times r times cosine theta over sine theta. And we come out with v equal to 1.18 meters per second. End of problem.